Hey, hello, welcome back to the channel Campus Coders. Today we will see some medium level questions in array. So, our first question will be find the majority element in the array whose count is greater than n by 2. Like for int I equal to 0, I less than n, I plus plus. Let's initialize count. Int count is equal to 0. For int j equal to 0, j less than n, j plus plus. We are checking if v of I v of I equals to v of j. If this is so, then we are going to increment count, and then we are checking if this count is greater than n by 2 or not. If it is so, then we are returning that element. So that's it. This is the brute force approach. This will obviously take O of n square for time complexity. We need to optimize this. To optimize this, the best way is to use um, maps here. So whenever we are getting a new element, we need to store that in the map, the element and their count values, and then by accessing that map, checking the counts, we can say that whose count is greater than n by 2. So that one would be something like, let's say, map int comma int p, and first we are going to store every elements in the map. That would be mp of v of I. V is nothing but the array here, vector. So after storing everything in the array, we are going to traverse. Sorry, everything after storing everything in the map, we are going to traverse the map. So how to item in map? We are going to check if the count of that item. So count will be stored in the second part, right? So we are going to access it to it dot second. It dot first will store the element. It dot second will store the uh, count of that element. So it is so then return it dot first. So this would be the other way of dealing this question. Uh, since we are storing this element in maps, it takes us extra time space complexity, right? So to optimize that, we are going to uh, learn a new algorithm. It's called Moore's voting algorithm. So I will explain the how this algorithm works. So let's take this array, and then obviously we are going to traverse one elements one by one. So elements and their count. Right, we are going to have their count as well. So first, count is going to be initialized as 0, and we are going to have first element here. Okay, so first element is 7, and then since and we are going to increase their count to 1, and then we are going to element next element is also 7, so we are going to increment their counts to 2, right? And then next element is 5, and since 5 is a new element here, so what we are going to do is remove this element, write 5 here, and then decrement the counter to 1. Okay, so what we are saying is, in this subarray, for till now, till this one, where the maximum uh, element is 7, right? And it is maximum by 1, because 7 and 5, they are equal, and then it is 7 is greater in count than 5 by one number, right? So we are tracking that number here. So after this, our new element is 7. So its count is going to be 2. Okay. Before that, I will let's not take this change this 7 and 5. We will just have it as 7 itself for now, because we are going to change this element only when the count is getting 0. Okay, I did mistake here. So I'll tell you what we are going to do. This count is actually that what I have said, the same one. Whenever we are going to, this count represents how much this element is greater in terms of other elements. Okay, so say we got another sound, we are going to increment it to 2, and then we are going to next element, it's 5, it's not 7, so we are decrementing it to 1, and then we are going to next element, it's 1, it's not equal to 7, we are decrementing to 0. Now we got it 0. So this 0, it means till this part of array there are as much 7 as the other elements. That means the number of count of 7 here is 3. The count of other elements is also 3. So it means 7 is not the maximum element here, right? So for now, this part of array doesn't work out in anywhere, because till this array it's 0. So whatever we are going to find in the other part of the array will be the answer, because this doesn't work at all, right? Because the it has maximum element as 3, as well as the other elements also equal to that count. So this doesn't take part. So what we are going to do is we are going moving to next element. So next element is 5, and we are going to change that element 5 here. Okay, so now we are going to have the count of this element 5. So we are going to increment count to 1, and then 7, it's not, it is not this same count, right? So we are going to decrement it to 0. Again, it is 0. So till this part, it is not going to work out, and then we are going to move to next element. Next element is 5. So again, it's the same 5. So that doesn't matter. We are going to increment it to 1, and then next element we are going to increment it to 2, and then next element it's 7. So we are going to decrement it to 1. Next element is also 7. So we are going to decrement that also to 0. So it's again 0. It means till this part of array that it's full 0. So we are going to next element 5. Next element we are going to change it to 5, and we are going to increment the uh, count of this 5. So just if you do this as such, you will get these elements as 4. So count is going to be 4. And since this is the final count 4, what we are going to do now is to check if the this is the majority element, because in this question they have asked if their count is greater than n by 2. Now for now we know that using this Moore's voting algorithm we can say that 5 is the maximum element, but we don't know if the 5 is if the count of 5 is greater than n by 2. So for that we are going to run another loop and check if the count of 5 is greater than n by 2. If it is so, we are going to return 5, or else we are going to say there is no element that has count greater than n by 2, because this itself is the maximum element. There cannot be any other. If this doesn't have count greater than n by 2, then there exists no other elements which can be greater than n by 2 count, right? So by this way we can do that. So the algorithm will be something like int count is it take count is equal to 0, and we will initialize an element for int I equal to 0, I less than n, I plus plus. If cn first, if count is 0, that case what we are going to do is we are going to initialize it I1, or we can just say incrementing either way it's fine, and we are going to change the uh, element, right? We are going to change the element, and else if element is equal to v of I, that means it is the element which we are finding for. If it is so, then we are going to increment the count, else we are going to decrement the count. So this part is over. So this one gives us the maximum element right for now, right? So to check if this maximum element is count is greater than by 2, what we're going to do is, let's say we are going to have another pointer, another count int1 equal to 0, and we're going to traverse it again I equal to 0, I less than n I plus plus. Okay, if it is so, if v of I equals to that element, we're going to increment that counter, and then if we're going to check if that count is greater than n by 2, we are going to return element, else return this one, right? This is the way of doing this question using the this algorithm. I hope you understood this way. Next question would be finding the maximum subarray sum in a given array. So if they have given an array, let's say this one, we need to find a subarray whose sum is the maximum among all the subarrays possible. So if the array has only positive numbers, the maximum subarray should be the sum of all integers. But thing is, the array can have negative numbers as well. So if there is some negative number, it there is a slight difficulty in finding which subarray can have the maximum sum, right? So for to find this one, the initial way would be something similar to what we did to find the longest subarray with given some k, that question, right? So what we did there was to find all the possible subarrays and then find the sum, right? So the same we get brute force approach we can do, like for example for maxi, int maxi will be, this is the brute force approach. Of course, this is so of n cube complexity. To reduce this, we will use the same method how we approached for that longest aberration. We will remove this, say, third pointer. We will add the sum whenever we are incrementing the end pointer. So the same thing we can do here as well. Int max is equal to int min. Then this one, but still this is of n square complexity. To find to optimize this, we are going to use an important algorithm, famous algorithm called Cardan's algorithm. It's to find the uh, maximum aberration here. So this is the algorithm which we are going to use here now. So this algorithm if says us not to consider subarray as a part of answer if the sum is less than 0. So for example, if we have an array here, and let's say we take this subarray. Okay, this subarray sum is -1 now, right? So any subarray which includes these two elements will obviously reduce the total sum, right? So if or now let's say we can take this subarray -2 1 3, its sum is also less than 0. The sum is -4, right? So if there exists some array that includes this subarray, that will obviously reduce this total sum of that elements in that subarray, right? If we don't have this part, then it will be obviously greater than what it will be when this is added. So what we will do is, whenever the sum gets 0, we are not going to consider that part of the subarray. So when sum is less than 0, subarray always reduces our answer, so we are not going to consider the subarray as part of our answer. That's the approach we are going to do. I will give the code of that so that you will get an idea. So let's say int max is equal to int min, same one, and then we will initialize sum here itself, and we are going to use only one pointer, and just like how we use approach the longest subarray with given some k, that question, we had only this first pointer, and then whenever we are going to add those elements one by one, and then whenever it is equal to some k, we are going to add it in a hash map, right? The same way we are going to do, we are going to have a only one pointer, that's going to go from starting to end, and then we are going to add that to the sum, and there we added if there we checked if it is equal to the target, we are going to add it in the hash map, right? Here what we are going to do is, if that's this sum is greater than maxi, first we are going to uh, do this part first. Whenever we are going to check if the new max sum is greater than maximum element, we are going to first update that. Then we are going to check if sum is less than 0, we are going to initialize it to 0. Some we are going to initialize to 0 because those part we are not going to consider at all. So after this, we are going to return the maxi. That's it. That's it. The problem. It's very simple. This returns the maximum sum. So if they have asked us to find the print that subarray, what we can do is we can have uh, at this place we will check if sum is equal to 0. We will have start pointer as I, and then same way at here what we can do is we will have and start pointer, answer start pointer will be equal to start, and then answer end pointer will be equals to I. So and then we can return these two pointers, and then we can print the subarray from starting from answer start till the answer end. That will be the maximum, that will be the subarray with maximum sum. So this is how we will solve this question using Cardano's algorithm. Question is a famous question: stock buy and sell. So, given an array of some numbers which represents the value of stock at that particular day, okay, we need to find the maximum profit that is a person can able to get from this. So this represents the stock values at each day. Let's say a person buys at day one and then sells at day two. The profit, it will be a loss of six, right? We need the maximum profit that could be get taken from this one. So this will be when we buy it on day two and then sell it on day five. So the profit will be 6 minus 1, 5, right? So this way we need to solve this question. The um, normal approach would be to find all the pairs that are possible. So one more thing we need to be careful in this is we cannot buy a stock on one day and sell it on the previous day, right? You cannot buy it on day six and then sell it on day two. So that's not going to be possible. So whenever we are going to buy, we need to check what day we can sell in the upcoming indexes, right? The other indexes we need to check. So according to that, so let's say we are buying it on day one, we will check if it is possible day two, day three, day four, day five, all those are possible. Pairs we will check. We will have a max profit uh, uh, variable, and then we will update it whenever it is greater. So that one we can do, and then when it is on second day, we will have same way we will do all those pairs, and then we will check. In this way we can do, this will be the brute force approach. I'll just give a gist of it how it works. you know let's say in max profit will be equal to 0 approach. Obviously it is 0 of n square, right? So by this way we can do this using brute force. The other way approach would be we can maintain a minimum from the starting of the array and compare it with every element of the array. uh, if it is greater than the minimum, we can take the difference and then maintain it in the max element, max variable. Else we will update the minimum. In this way we can do. I will just give that code as well so that you could understand it better. First we will have a max profit, initialize it to 0. We will first have, and then we will have minimum price. We will have it to int max. Okay, so again, we are going to traverse through the array. So first we will check is if exists there is a minimum price. Okay, whenever it is minimum, we are going to store that in the min price, and then we are going to check the max profit as well. Max profit means we are going to do here of I minus min price. So when we are, because whatever day we are getting, we are going to sell it. If we buy it in the lowest price among the whole array, it's going to be profitable, right? Whenever it is, we are buying in the lowest price, and then the maximum price of a subarray greater than the index of the buying date, that would give us the maximum profit. So accordingly, this code will work. So this is the optimal approach of n complexity, obviously. So yeah, this is slightly trickier question. So given an array, we need to find the next lexicographically greater permutation. So let's say they gave an array of 132. We need to print 213, and if they give 321 as the array, we need to print 123. So it's the permutation of the this array. So let's say there are three numbers. Okay, one, two, and then three. Other one. So if they give the last number, what we need to print is the first one. So this will be cyclic as well. So based on this, we need to do where in whatever array they give. Okay, if it is the last permutation, what we are going to do is we are going to print the first one, right? So last permutation will always be the decreasing array, right? Decreasing array of that given elements. So when we find if the array is decreasing, we are just going to reverse it, or we are just going to sort it. We will get the next permutation, right? That's one case we need to check. So to find if an array is decreasing or not, what we can do is from last we will traverse if the elements are just getting greater at every point till the last, till the starting point of that array. It's obviously going to be greater. But if there exists some element which is lesser than the previous element, let's say here 2, and then we are traversing to 1 which is less than 2, right? If it is so, this is not the case which we are finding for. So what we can say is this part is the breaking point. Okay, so we need to first classify whether it's the special test case or the normal test case. To find that, we need to find if there exists a breaking point. If there exists a breaking point, it means it's the normal test case. If it is not so, till the end of the array, it is the special test case point. So first step is to find breakpoint. So what is breakpoint here? The first index I from last where a of error of I is less than error of I plus 1. If there exists, we need to find for this breaking point. This is one thing. But if here, so 1 2 3 1, so in this one the breakpoint is 1. So what we are going to do is we need to find for the least element after this breakpoint, because that's going to take the role of the index before this breakpoint, right? So we will find for the least one. The least one is 2 here, so that will come all the way this side, and then we are just going to do this one the similar way. Now if we come here, the breakpoint is 1 here, right? So we'll find for the least one is obviously the only one here. We are just going to swap it this way. The same way, if we see here, 1 is the breakpoint, we are just going to swap them. Here, the least one is 2. Sorry, 2 is the breaking point, the least one is 1. We are going to swap these two, right? So while here, if we are seeing 2 is the breaking point, when we are swapping this 2 with the least one, we will get 1, 3, 2, right? But to get the final part, what we are going to do is to reverse the entire array, right? I mean the right side part of the array. So by this way, we can say this is the uh, way we can find this one. So whenever the breakpoint exists, what we are going to do is find smallest number greater than a of I. After that point, whatever we are going to, after this breaking point, whichever the smallest number, we are going to find that. That should be greater than a of I, as well as it should satisfy the condition that it should be in the right half of that one. Right half means it should be between the index I plus 1 to n minus 1, right? After finding this, we are going to swap it with error of I. Okay. After doing this, we are going to reverse the right half. That means index from I plus 1 to n minus 1. This part we are going to reverse it, right? So I hope you got the idea how this works. So let's have a code of this as well. So first we will have the index breaking point as -1, initialize it, and then we are going to traverse it from the last. Okay, so int I equals to n minus 2, I greater than equal to 0, I minus minus, right? So if a of I is less than a of I plus 1, what we are going to do is we are going to update the breaking point and then break from the loop. And then if there is no breaking point, we are going to reverse the array. It will be something like this one in C++, error print, and then return array. Okay. If there exists some breaking point, so what we are going to do is for int I equals to n minus 1, I greater than index. That means we are traversing from the last till the where the breaking point is there, right? So here we are, and we are going to check if a of I is greater than a of index. There exists some element greater than the index. We are going to swap AR of I, swap them, and then we are going to break it there itself. After doing this, we are going to reverse from index plus 1 till the end of the array, right? And then we are going to return the array. This is how this works. To find answers to questions like this, we need to have an example so that we could find the what is getting uh, repeated. So by observing these cases, we can say how this works so that we can code the same in the interview. So yeah, that's it for today's video. I hope you have learned a lot of things in this video. The links to the questions will be given in the description below. You can definitely check it out and practice them. You can follow me in LinkedIn and Instagram. The link will be given in the description below. So yeah, I will meet you in the next video. Until then, keep coding. Bye bye.